In this tutorial, we will see how to complete an entry-level electrical configuration. After having created the buildings in 3D, and having outlined the type of coverage, it is obviously necessary to have completed the positioning of all the modules. At this point, we can proceed with the electrical configuration by clicking on the inverter icon. Here we can find all the fields that we have created, that is all the areas where we have placed panels. In this case, sheet metal slope and tile slope. Let's assume that we want to complete an electrical setup only on the building with a sheet metal roof. It will be necessary, first of all, to select the field we are interested in. The system highlights the selected slope in the scene, and offers us filters to be applied to the search for inverters. Based on the filters that we are going to insert, inSun will only show us the inverters present in the catalogs that are suitable and compatible with our research. The system recognizes that in the field we have selected, the peak power is equal to 44 kilowatts, for a total of 126 modules, and automatically sets a filter for the power of the inverters, from 0 to 44 kilowatts. This parameter can obviously be modified. For example, by entering 50 kilowatts, the system will show us the inverters from 0 to 50 kilowatts peak. Here we have some other very important filters: single phase or three-phase, and the phase neutral, 230 volts. The possibility of setting filters is very important, because it helps to avoid choosing an inverter, which might seem suitable, but which is then incompatible with the network characteristics of the building. Once all the search filters have been set correctly, we can click on Go to Inverters. The system shows us the catalog of inverters, and we can choose the brand that interests us. We are going to use ZCS. Here we will find all series of inverters, filtered according to the criteria we have set. In this case we have to satisfy a power of 44 kilowatts. We could therefore think of using two 20 kilowatt inverters. By selecting an inverter of 20, we are shown the product specifications, and we can see that this choice could be suitable, as with two inverters, we will have a power correctly sized compared to that of our system. Among the data of the inverter that we have chosen, we also have the possibility to select variants, if available. These usually differ in the presence or absence of onboard surge arresters, or fuses. Once we are sure of our choice, we can click on Calculate. inSun will show us, at this point, a new page, from which we can go to carry out the dimensioning of the strings. Based on the power of the system and the inverter we have chosen, the system suggests us what is the correct number of inverters to use. In this case it is 2, having chosen a 20 inverter for a 44 kilowatt system. Confirm. At this point, we will have inverter 1 and inverter 2, with the relative MPPTs. In this case we have chosen inverters with 2 MPPT each. The next step will be to divide and assign our modules, which are 126 in total, to the various strings that will converge in the MPPTs of our two inverters. If we want to speed up the process of assigning modules to strings and MPPTs, we can let inSun calculate it automatically. By clicking on the Calculate button, the system will highlight the number of modules that will be assigned to each MPPT of each inverter. In this specific case, it has assigned 2 strings of 17 modules to the first MPPT of the first inverter, for a total of 34 panels. In the second MPPT instead, it created 2 strings, from 15 panels, for a total of 30 modules. The same situation occurs again for the second inverter. If we are not satisfied with the configuration that the system has created, we can go and modify it manually, always bearing in mind that it is essential to satisfy the entire number of panels we have available. Once we have defined our stringing, we can apply the fields. At this point, the system will have loaded our 2 inverters. By clicking on the blue arrow, we can examine the inverter, and see how many MPPTs it is made up of, and how many strings we have for each MPPT. We can eventually assign some string boxes, if necessary, but in this case, we have chosen inverters with onboard dischargers, and therefore they do not need to be used. To place the inverters on the scene, we have to click on the magic wand, and select the inverter we want to insert, drag it into the scene, and place it on the wall. Let's also select the second inverter. We drag it and position it in the scene. Once we have placed our inverters, we can assign all the fields. And here is that inSun creates the diagram of the strings and connects all the cables to the inverters. It is also possible to choose the direction of the lacing. In this case it was done vertically. You can see that the modules are connected following a vertical line with each other. If we select the horizontal direction and click on Assign to all fields, the system will update the lacing horizontally. In this case, it is appropriate to choose the setup that allows us to save more meters of cables. Once we have chosen the configuration, we can save it. In the last box we will find all the configurations we have saved. By clicking on them, we will always have the drawing of the lacing available. If we want to rename it, simply add a new name in the Rename Configuration field and click on a blank space. You can see that the name will be updated.